Have you ever heard the term sensor and noticed how industrial machinery operates smoothly without human intervention? Ever wondered how these automated machines work so seamlessly? It's all thanks to industrial sensors. Let's take a closer look at what an industrial sensor is and how it functions. Let's find out what an industrial sensor is. An industrial sensor is a device used in automation systems to detect physical changes in the environment and convert them into signals that can be measured, monitored, or processed by control systems like programmable logic controllers. These physical changes could include variables like temperature, proximity, or liquid levels. The sensor converts these physical quantities into electrical signals, allowing the control system to interpret the sensor's data accurately. As you can see, various environmental conditions need to be measured in industrial automation systems. Different types of industrial sensors are available for specific applications. Let's move forward and take a look at what these sensors are. Let's see what are the types of industrial sensor and their application. Number 1. Proximity sensor. Example: photoelectric sensor. Photoelectric sensors detect objects by interrupting a beam of light on conveyor belts, allowing for accurate counting and sorting of products in manufacturing and packaging processes. Number 2. Temperature sensor. Example: RTD sensors. RTD sensors are used to monitor the temperature of liquids stored in large industrial tanks, such as those found in food processing or chemical manufacturing facilities. Number 3. Pressure sensor. Example: differential pressure sensor. Differential pressure sensors measure the pressure drop across filters in systems like air, water, or hydraulic filters, helping to determine when maintenance or replacement is needed. Number 4. Level sensor. Example: capacitance level sensor. Capacitance level sensors measure liquid levels in storage tanks, monitoring and controlling the levels of various chemicals to prevent overflow or running dry. Number 5. Flow sensor. Example: electromagnetic flow meter. Electromagnetic flow meters measure the flow rate of water or chemical additives in water treatment processes, ensuring accurate dosing and flow measurement. Number 6. Position and displacement sensor. Example: rotary encoder. Rotary encoders are used to monitor and control the position and movement of robotic arms in automated assembly lines, ensuring precise and reliable operation. Now that we've looked at different types of industrial sensors, you'll notice that they don't all operate the same way. The working principles and applications of these sensors vary based on their construction. However, we can classify them into two main categories based on the type of signal they produce: analog sensors and digital sensors. Analog sensors measure continuous physical variables and output a continuous electrical signal. Also, analog sensors can provide a wide range of values that represent varying conditions of the measured parameter. In contrast, digital sensors detect on, off, or high-low states, providing a signal with only two possible outcomes. In simple terms, digital sensors detect the presence or absence of an object, resulting in a binary signal output. Let's move another chapter to close look at how these sensors work and their working principle. In this section, we'll explore how industrial sensors work by focusing on two types: the inductive proximity sensor and the RTD sensor. First, let's look at how the inductive proximity sensor operates. The primary function of an inductive proximity sensor is to detect the presence or absence of metal objects without physical contact. The sensor has two main parts: an oscillator circuit and an internal coil. When the sensor is active, the oscillator generates a high-frequency AC current that flows through the coil, creating an electromagnetic field in front of the sensor. When a metallic object comes near the sensor, it alters the effective inductance of the coil. This change is detected by another circuit within the sensor, which then activates the switching component. Let's see how RTD sensor works. Before we dive into the details, let's take a moment to see what an RTD sensor looks like. An RTD sensor, or resistance temperature detector, is a temperature sensing device that looks like a small metal probe, usually cylindrical in shape. Inside it has a thin wire made of materials like platinum, nickel, or copper, which is coiled up and protected by a metal casing. The RTD sensor operates on the principle that as the temperature of a metal wire increases, its resistance also increases. An RTD sensor measures temperature by using the resistance of a material. Simply put, an RTD sensor functions similarly to a resistor that is exposed to temperature variations. When the temperature changes, the resistance of the material changes as well. This change in resistance is the key to detecting temperature fluctuations. To measure this change in resistance, an electric current is passed through the sensor, and the resistance element measures the current in ohms. The resistance value is then converted into a temperature reading. Just like the proximity sensor, the RTD sensor also sends an electrical signal to the controller. However, this signal is analog, meaning it represents a continuous range of values rather than just high or low states. You have just seen two different types of sensors and their working principles. You might have noticed that both sensors send signals to the controller, either as voltage or current signals. This highlights a common feature among sensors. They typically have power wires and signal wires, or a data input wire that transmits the signal to the controller. Additionally, some sensors require operating voltage from an external power supply. Typically, the operating voltage for industrial sensors is either 12 DC volt or 24 DC volt, as these are common operating voltages for most PLCs. In this chapter, we'll learn how to connect an inductive proximity sensor to a PLC controller. But first, let's take a moment to look at the sensor itself and its pinout configurations. Here, you can see three inductive proximity sensors, each with a different pinout configuration. The first sensor has a 2-wire pinout, the second has a 3-wire pinout, and the third has a 4-wire configuration. You might be wondering why there are different wire configurations. Don't worry, we'll go through this step by step. Before connecting an inductive proximity sensor to a PLC controller, there are a few key points to consider. Determine whether your sensor sends a digital or analog signal. Identify whether your PLC controller uses syncing or sourcing inputs, as the proximity sensor will be providing a digital input signal. Understand the signal type the sensor sends. Is it an NPN signal or a PNP signal? If these terms sound unfamiliar, don't worry, we'll explain everything in detail. In a PLC system, the terms syncing and sourcing refer to the direction of current flow. Syncing is associated with NPN types, while sourcing is linked to PNP types. Let's consider a PLC digital input card, which receives digital signals. When the PLC receives 24 DC volt at its input terminal, it detects this as an on condition or a high state. This happens because, when the sensor is active, it completes the circuit with the PLC's power supply, allowing current to flow between the power supply and the PLC ground. If the current flows from the PLC input module to the sensing device, it is referred to as a sourcing PLC. On the other hand, if the current flows from the sensing device to the PLC, it is known as a syncing PLC. I hope this clears it up. Now let's take a closer look at what NPN and PNP sensors are. Simply put, NPN and PNP refer to the type of signal the sensor sends. Just like PLCs can be either sourcing or syncing, the sensor type indicates how it should be connected to the PLC controller. In a PNP sensor, when the sensor is triggered, it outputs a positive voltage to the PLC controller. In contrast, an NPN sensor outputs a ground signal to the PLC controller when it's activated. In summary, the PNP sensor requires an NPN-type PLC controller, while an NPN sensor requires a PNP-type PLC controller. Now that you're familiar with the terms syncing, sourcing, and the sensor signal types NPN and PNP, you're ready to connect an inductive proximity sensor to a PLC controller. In a 3-wire configuration, 2 wires are for power, and the third wire connects to the PLC input terminal. The wire color code typically is brown for positive 24 DC volt, blue for the common terminal, and black for the signal input wire. This black wire could be NPN or PNP, so it's important to select the correct sensor type that matches your PLC input card. In this setup, the brown wire of the inductive proximity sensor is connected to the 24 DC volt positive terminal of the power supply, while the blue wire is connected to the negative terminal. The black wire, which is the data or signal wire, is connected to the PLC input terminal that accepts digital signals. Earlier, we mentioned different wire configurations for inductive proximity sensors. Now, let's explore why these configurations exist. As for the 4-wire inductive proximity sensor, it's similar to the 3-wire configuration, but with an extra wire. This extra wire is what makes it flexible. It allows the sensor to support both NPN and PNP types. Now that we've explored the definition, types, and working principles of industrial sensors, and walked through the process of wiring them with a PLC controller, it's time to bring everything together in our final section. Let's conclude with a quick recap and some key takeaways. In this video, we covered various types of industrial sensors, including proximity sensors, pressure sensors, and level sensors. Industrial sensors can be broadly categorized into 2 main types: analog sensors and digital sensors, based on the type of signal they send. Digital sensors detect the presence or absence of an object, while analog sensors monitor continuous changes in a variable. Both types send signals as either current or voltage signals. Most sensors have wiring configurations that include power wires and signal wires, with some sensors requiring additional power for operation. This operating voltage is often 24 DC volt, matching the voltage of most PLC controllers. When wiring a digital sensor, it's crucial to determine whether your controller is syncing NPN or sourcing PNP to ensure proper connection.